Hello, let's look now at the fracture behavior of steel fiber reinforced concrete. Given the excess amount of information regarding steel fiber reinforced concrete available in the internet, this lesson is based on examples performed in our laboratory with the aim of emphasizing the most relevant characteristics of steel fiber reinforced concrete in fracture, which are at the end the most relevant ones. As shown in previous lessons, the main structural requirements and values for design are extracted from fracture tests. Such tests are commonly 3-point bending tests on a notched specimen, as the one shown in this slide. The test is controlled by the crack mouth opening displacement gauge, and two extensometers measures also the deflection in the mid-span. This slide shows the typical curves of concrete reinforced with steel hood fibers. The shape of these curves, load crack mouth opening displacement and load deflection, show a post-cracking short softening stage down to values around 60 or 80% of the peak load, where the curve stays almost steady up to an approximate crack mouth opening displacement value of 2 mm. The following unloading process caused, whether due to the failure of the fiber itself or the failure of the anchorage, was pronounced and followed by a small recovery. Indeed, a staggered decreasing takes place. That is an overall behavior, with curves increasing in load values proportionally to the fiber content. It is important to highlight that with important amounts of fibers, it is possible to achieve even hardening behavior. We will compare steel fiber reinforced self-compacting concrete with various dosages to assess the influence in the fracture behavior. One mixture was manufactured with 50 kg per cubic meter of 35 mm long steel hood fibers, and another one with 70 kg per cubic meter. In another mixture, the two types of fibers were mixed in equal weights up to 70 kg per cubic meter. If we see these curves in this slide, we can identify such improvements due to the increment in the fiber dosage. Note that these are the mean curves of 6 specimens of each concrete type. Note also that average curves do not represent the staggered shapes, as the rectification of the hooks do not take place in the same deformation necessarily. Looking first to the curve with the lowest fiber content, we see that the curve stayed almost steady after the softening process. When 50 kg per meter cube are added to the mix, some pseudo-hardening can be noticed, and reaching higher values of load that obtained in the limit of proportionality. The hardening becomes evident with the addition of 70 kg per meter cube, as shown in this slide. That behavior is optimum, without any loss of stiffness and with fibers bridging the crack opening. If we compare the fracture curves using the combination of two fiber lengths, we can realize that the result is improved. The best post-cracking performance with the two types of fibers is due to the combined actions of the short fibers with initial crack openings and the longer fibers for higher deformations. Just as a reminder, keep in mind that the structural requirements of the Model Code and Spanish Concrete Code are that the strength at crack openings of 0.5 mm has to be higher than 40% of the strength at the limit of proportionality. Furthermore, the value of strength at 2.5 mm of crack opening has to be surpassed 20% of the strength at the limit of proportionality. Such values are commonly named FR1 and FR3, respectively. And moving on to the values of such residual strengths, note that the values of strength at the limit of proportionality, in this case with steel fibers, increases proportionally with the addition of fiber. Concerning the values of FR1 and FR3, all the concrete types met the requirements of the standards and therefore can be considered to be used as a structural fiber reinforced concrete. Note also that values of FR1 and FR3, which are the representative ones, are very similar for all the concrete types, in contrast to what happens with other types of fiber reinforced concrete. And let's summarize by saying that steel fiber reinforced concrete is the most common solution when structural capacities are required, given its outstanding tensile residual strengths. Thank you for your attention.